So, hierarchies, naming conventions, and prep for rigging. So, while this sounds pretty unexciting, this is one of the most important tasks when preparing an asset to be used in a pipeline, to be used by different people, to be prepped for rigging. There's going to be some interesting stuff in here. So, concepts like HiRes or SRT buffers and masters, things that zero out rotational values for you to easier hook up some controls. There's going to be some hidden tips about renaming stuff in Maya. I'm not going to go into Mel for search and replacing object names, but there's some little tools that you can use that are actually quite handy when renaming a lot of objects. But to be honest, this will also feel like the most unexciting chapter of the series. Because we're gonna go into renaming objects and what the structure of of a good name could be. This is definitely also a matter of opinion. So just as a warning, um, this chapter might drag a little bit because there's gonna be a lot of stuff to cover here. I still hope there's valuable information for you in here because this is an important task after all. So let's get into it. So, as I said, those general concepts of naming conventions and how to organize your stuff within a scene files will vary from project to project, maybe even. But there's just some general ideas. They're not fixed rules or anything, but it's just kind of like things that have proven to be working very well in production. So it's usually kind of important, just as important as thinking about how you're versioning your files, uh, whether you're using the no letter identifier or just a number, or you're using the typical V like V16 as in version 16 or E as an edit number. I usually prefer a lot of shops and pipelines do that differently, but I prefer the E as an edit if I'm working on something. So I'm currently saving versions of this file, while recording to pick up at the point I left the recording. So it's an edit number. And the V usually for me anyway, and it will differ from project to project as well, but usually for my own projects, um, this will usually a V version or a version 01 or 02 will usually be a version that goes somewhere like your client, your supervisor, your whoever it is for reviewing your assets. So if I have to change something, he's going to get a version 2, and that might actually be, if this is E16 and I had to do a lot of work, my version will probably be something like E150 because I've done 150 minus 16 steps in between to actually produce this version 2. So, but this just one naming convention that you can use. So this is what we use at the lab. This is what I usually recommend just because it works with our system. Um, but you can do that differently. It's just usually important that you stay consistent, at least within one of the same project. You might change your naming conventions because they don't fit another project or something like that. And there's always things to improve. So the naming convention I used here is definitely not the naming convention I'd use on something more complex. And as I said, I took a few shortcuts compared to a asset created to the absolute highest standard that you can actually produce, if there is even such a thing, because this is just a matter of opinion as well. Having said that, let's take a look at how this model is actually structured. And after taking a look at the actual mesh hierarchy and how our geometry is actually structured within the scene file, we're going to move over to the control rig because those two things are actually pretty much connected with each other. Usually, as a general thing, your geometry usually doesn't have anything to do with your rig. So usually there's no correlation between them whatsoever, other than the fact that every piece of geometry that you have will have to be moved by the control rig or by joints if you're using them on a character. In this case, there are no joints on the plane except for a little part down here at the gear, which we'll take a look at later. But usually they will be parent constrained to objects within the control rig. If you're like me and you don't like constraining, because I find parent constraints or any kind of constraint in Maya actually pretty confusing when taking a look at it at the node editor, you might want to use your own matrix marv or vector marv to pin objects to other objects, or if you're on Maya 2020, which I am actually, and I try to use some of the new features of the version. I've just recently switched from 2018.6, which was a pretty stable version. You can use offset parent matrix, which is new, which is pretty handy rigging tool, and I'm gonna go into this a little bit later on when talking about the actual rig that is currently hidden. But just to say, there are a lot of ways to actually make a connection between your geometry and your control rig. In this case, I did not strictly make a difference between my standard hierarchy of geometry objects and the controls group. As you can see, here is an orient constraint that I'm using to connect this master group to the rig. I kind of switched a bit between constraints and offset parent matrix, depending on what I just preferred in the moment. In this case, on a production, I probably stay consistent, but since parent offset matrix is pretty much new, so this is the transform offset parent matrix. In the attribute editor, it's actually a node connection. I try to use change the ways a little bit, because I still don't really trust it to actually work in all cases, because Maya tends to be a little buggy with every new version, and it usually takes a few service packs to really kink out these issues or get rid of those issues. So yeah, little tangent to rigging here, but it is important because your hierarchy, or in this case my hierarchy, does have some connection to the actual rig setup. So coming back to the panels right here, even if I had combined all these surfaces into one single mesh, there'd still be a lot of surfaces and a lot of mesh that I can't combine on a plane like this. So it has flaps that can move down for slowing the plane down for landing. It has ailerons like here, which are responsible for the steering of the plane. You have the rudder, you have the elevator, you have some doors that are opening, closing, gears, the actual cockpit canopy and stuff like that. So those would of course be different objects. And all in all, there's a pretty large number of objects actually for such a, well, it's not small, but compared to a modern fighter jet, it's definitely small plane. So you have to structure it in some way, and the way most productions tend to structure objects is by a very simple system, which is just left, center, right. So you usually have an asset that has a left part, a right part, and a center part. And basically everything is split into these three sections. So that when I go in and I have to change something, or I have to select certain parts of the mesh, I know that they are probably in a group called center. If they are close to the middle, know if it's the left wing, it's probably in the left group. But usually there's just some left group, center group, right group just on the top of the hierarchy. But in the end, I decided on a slightly different way for this asset, because I found it important to have a kind of flat hierarchy, because I didn't want to dig through like 20 levels of outliner hierarchy right here. So I decided to just group parts roughly based on left, center, right, but maybe more into general parts of the plane that I would have to modify. So yeah, let's take a closer look at this structure. So as you can see here, the actual group, the master group, is has this suffix group. You don't actually need that really because you can see that it's a transform, that is a group. But I usually like to name objects based on their intent. So I know that this is pretty much a group that's mainly used for sorting objects, so that it's not necessarily used as a transform. In that way, this master group, the P51D asset group, is not a transform as well. So you can see I also locked the movement or the ability to move it, so I can lock these attributes in Maya. So I don't even get the idea that I should actually pull on any of these axes and try to move it around, because if I did and if I would, I'd probably break the whole control rig, because I'm introducing offsets in the world that are not intended, and things like to get a double transform where an object is maybe transformed because it's moved to the side, but its control object also moves it to the side, so basically it's moved twice, and you usually want to avoid that very much. So I called this group hierarchy, and I didn't give it the group suffix just because it's a hierarchy. It's obvious what it is. And this is also just a purely organizational group. And within it, there are basically the subgroups that are used to, split apart the different parts of the file. So the very first thing there is just this pilot attached null. It's called, it has the suffix null because it's just that. It's a null, it's a point in space, and it's nothing more. So it pretty much says what it is. This plane, of course, has a pilot. I've currently hidden the pilot. I can unhide it, and as you can see, that's a pretty low poly pilot asset, but of course I can't do any shots with it without having a person in the cockpit, so I took the time and maybe an hour or something like that to quickly model a pilot based on the face is actually based on a 3D scan that we did with a structure sensor. So I used one of my co-workers as a reference and retopologized his face, and then just added some geometry around it. You can take a look at that time-lapse video as well once it's uploaded. So this is nothing complicated. It's just a pretty standard human IK rig. So I do have my standard HIK control objects. I didn't spend much time rigging the pilot, so if I just move the arm around here, you can actually see that its elbow, it's not actually at the correct position because the auto rigger screwed up, but honestly, you will never see much more of the pilot than this, so just didn't take the time to correct it and just lived with the outer rig that the human IK gave me. So there's this human IK character. It's P51D pilot E01 namespace and P51 pilot. It's the only thing I kept in a separate namespace because it's a completely different thing, this pilot. You might change that later, and that's the reason why there is this pilot attach null. So I can just attach the pilot to the plane, and it's a point somewhere in the plane. It's moved about with the whole rig, so the pilot stays right there relative to this point. And so I can keep the pilot outside of the actual plane's hierarchy, because the pilot is not part of the plane, and he's of course sitting in the plane, but technically speaking, those are two different assets, and I want to keep them separated. So yeah, that's that. As I said, nothing complicated, just a standard human IK rig. Pretty much standard stuff. So yeah, I'm just gonna hide it again because we currently don't need to see and don't want to talk about the pilot. After this pilot attachment, maybe one last thing. So if I go to the node editor, which I spent a lot of time in later. I talked about constraints. In this case, for the pilot, I've got these tabs in the node editor with all the different control group setups. This is sim attached to rig. No, this is sim attached to rig. This is pilot attached to rig. So this is actually attaching the pilot to my pilot attach null. And in this case, instead of using a constraint, because this is a very simple connection, there's nothing much that can go wrong. It's just taking the pilot's matrix and just connecting it to the offset parent matrix. The attach null matrix, taking the attach null world matrix and just connecting it to the pilot's group offset parent matrix, or better said, just its control reference groups, which are his control objects. And it's just in the way this connection is built, the world matrix is just transforming this pilot along with it. So when a plane rotates, pilot rotates with it relative to the plane, so it stays in the same spot relative to the plane. So yeah, that's that little course to the rigging stage. But anyway, those as I said, those things are connected. You have to think about those things sometimes, at least if you're doing the modeling and maybe also the rigging, which almost never happens on a large production. But still, you might be asked to prepare an asset at the model stage in a certain way, so the later parts of the pipeline can actually work with it comfortably. So before moving on into the deeper levels of the hierarchy, let me just re-enable the lights, and I don't want to use the default material anymore because I just want the viewport to look a little bit nicer. And I'm gonna turn on hardware texturing, and just to make it look even better, I'm gonna regenerate all our UV tile previews to make things a little bit nicer to look at and to see some reflections in the viewport. Actually, those reflections, to come back on a very different tangent, which has to do with modeling, use reflections in the viewport to check your curvature. You can see bumps in the surface and things like that right there in the viewport. You don't have to do any re-rendering again and again. I guess rendering goes pretty fast. I usually render on the GPU. I can't because I'm on the Mac right now. So you can check your reflections in the IPR, but really the viewport is just so much faster at doing that, and you can check your curvature flow, and you can compare it to photos and kind of like decide whether your surface flow is correct. So this is why I like to use reflections in the viewport. But as I said, tangent, I'm going to go back into the hierarchy here. So if I just take a look at the main groups here, you can see that they have a suffix, which is LCR, LCR, C, LR. So obviously C, L, and R stand for left, right, and center. And because it just made more sense in this case to have kind of like the center fuselage, which is more or less one piece on the plane, or at least the piece that the wings get attached to kind of like put everything that has to do with the fuselage into this group. So I have this group here, which is just the centerpiece, and the actual plane is pretty much built the same way. This underwing part is actually part of the wing assembly, but I wanted to be connected to the body, so I put that in there. After all, this is just a vertical plane and doesn't have to fly in reality. So you can see that now, after those main groups, which I didn't give the suffix because they are kind of like, it's obvious that it's an organizational group, there are the geometry groups. So I split this fuselage LCR group into subgroups, and they are holding the actual geometry. I color-coded some of the things here. I tend to like to use green for some personal things, so I decided to use green. Some productions never use the actual ability to color things in the outliner. I never used it for, well, it's actually doesn't exist that long, but I kind of like adopted using color coding in the outliner to group things, just because I find it visually easy to discern. But you could of course discuss for a long time on how to color code things. This is kind of arbitrary. Why I chose green, this light green. I decided to color the cockpit differently because the interior part, because the gear assembly is usually hidden. If the plane is in flight, I decided to just color code them yellow. You can see at one glance the different parts. So this is all just geometry. This is something different. Yeah. So basically, it makes sense in a way just from a purely visual standpoint. Under this fuselage group L are all the the left group, or all the parts that are part of the left side of the plane. So this is everything that's grouped in there. And as I said, most of this would probably be combined into one mesh, except for the engine exhaust here. But I decided to do it differently this time, just because, well, as I said, my shading purposes. So yeah, that's it. This is just the right side. The scoop interior, which is this part here down at the bottom, which is part of the oil cooler and radiator assembly of the plane, and things like that. So I grouped the tails separately, just because it made sense. It's a different part of the plane. There's a lot of moving parts. Well, the elevators are moving, the rudder is moving, those little trim tabs with that are part of the rudder or elevator assembly are moving as well. So yeah, it's kind of like a different part. The wings are different parts. So if I just go into the tail here, I've got the horizontal stabilizer left and right, and the rudder, which is again suffixed with a C. And if I dive down to the very lowest level of the group, you can see something that you may have not seen before, or may have not seen labeled the way I did it before, because conventions are very different from either shop to shop or any kind of production, really. I don't really know why I use SRT buffer or SRT master. I could use HiRes as well. So yeah, before going actually into HiRes, SRT, what they are, maybe a bit of general concept again. Normally, so these groups, this rudder C group is a geometry organizational group. Usually you just have the geometry in there. As I said, I kind of like, in this case, mixed the rig controls with the actual hierarchy, because it just was easier for a technical object this way. So these buffer and master groups are actually part of the rig in a way, as in that they do make it easier for me to actually hook up the controls to these surfaces. And this is a general concept that has to do with local transforms and the way rotations are computed in computer graphics. So I'd like to show this on a simple example, and then I'm gonna explain what I actually mean by calling things SRT buffer and SRT master. So yeah, I guess the thing I want to do is get back into the terminal and just fire up the second Maya instance again. Just should just keep it open, actually. So back in our second Maya instance, I'm just going to use it to quickly demonstrate what an SRT buffer, a master is, and why I tend to group things the way I do, which has a lot to do with convenient control over rotations. So I'm just going to create a standard cube here and scale it a little bit, just make it a little bit broader, and maybe take some of the vertices here, and kind of like create a kind of rudder or elevator from it. So after having modeled, I'm going to freeze its transformations. So just making sure that translate, rotate, scalar are gonna get reset. So everything has a scale of 1, which is pretty important for a lot of things. Not gonna go into that right now, but usually you don't want to have things with absurd large or small scales. So in this case, this object is has a scale of 1. That's a size. I'm not going to scale it. Within it, the vertices have their position. I can measure its distance, so I don't need to have any value in scale to find out how large this object is. And procedural shaders and the like usually take the object size into account when, like a noise, when calculating how large it's displayed on an object. So if you want to use the same noise, for example, just an AI noise on a lot of multiple objects, and you want to have this noise be the same size everywhere, you're pretty much forced to have those objects have the same scale. So usually that's a scale of 1. So yes, another tangent. I'm just gonna duplicate the thing, and I'm just gonna move it off here. So it's basically the other part of our thing. So what I can do is just move off the pivot off to the side here of my actual elevator, and I'm just can use the Z rotation to transform it. So while modeling, I probably usually don't change the pivots much, and I just might take my objects, move them off to the side, and say that this kind of like something like a V-shaped tail of a plane. My objects will now have world rotations. What does it mean? So if I don't have them parented anywhere, and if I want to rotate this elevator around again, or in this case, it kind of like becomes a mix between elevator and rudder, I'm not really sure. First of all, its pivot point is at the incorrect location, so I can move that again if I want to, and I can rotate this part and see what happens when I rotate the part right now. Since it's already transformed in world space, it's gonna rotate about all 3 of its axes. Even though in the viewport, I'm just dragging its local axis, and it's actually gonna transform on all 3 axes. If I want to hook up some kind of object to control the rotation, or if I just want to animate the rotation of this thing, I don't want to animate 3 values, because that's prone to produce errors along the way. So what I usually have, and this will be pretty much always the case, this will be grouped into something. So maybe that's just how this is the, let's call it a rudder. Let's call it a stabilizer. That's just a stabilizer geometry group. So there's everything that has to do with our stabilizer. And there's this thing, and I'm gonna just call it control surface. That's this thing I'm gonna move, plane's control surface, and it's just the stabilizer geo, and that's actually the control surface geo. So you don't have to use a suffix, because you can see kind of like see that this is a polygon object. But well, at a quick glance, I just find it easier to just read. And so I know this is just geometry. That's not a null object, it's not a transform, that's not a control object of any kind, it's just geometry. After all, I do want to animate this control surface. And since this group is still just oriented in worlds along the 3 world axes, it of course is still gonna move about its 3 axes. So I kind of have to do something with it, and that is buffer it. So I'm just gonna duplicate my surface here, and I'm just gonna display shapes for a moment here. So the shapes in Maya, as you pretty much probably know, are holding the actual geometry, so the polygon data of the object. So I can just get rid of any object shape, and what I've produced from this is just an empty transform and an empty null object, and I can use that. And conveniently, it's at the very same position as my actual control surface. So I'm gonna call this a buffer, because this thing is gonna be responsible for zeroing out my transforms. So if I just parent this geo to this buffer, the buffer will have rotations in world, and it might have rotations on all 3 axes. I don't care for that. That's a buffer. I'm not gonna touch that. If I select my actual surface, since its rotational values are relative to the parent object, everything is zeroed out. And if I just move it about its local z-axis, the only value I have to care about when animating this object later, or when hooking up any kind of connection to this object, is the rotate z value. So I don't have to care for anything else. In fact, I can just select everything else in the channel box. I can just lock and hide selected. I can take the scale, which I don't want to change ever, and lock and hide selected. And if you don't even have a control rig and just want to animate some geo, this is pretty much all you have to do. So in this case, I just have a rotate z value. So as an animator, I definitely know that's the thing I have to animate. Everything else is locked anyway, so I can't. But yeah, I can just, if I set this to a lower value here, I can just animate the thing, and it will do exactly what I want with just modifying one value instead of 2. So what I usually tend to do, you can just call it buffer. Most people will tend to call this HiRes buffer, because if you take a look at an object's transform, you've got translate, rotate, scale values. So it just is natural to just kind of abbreviate it to something short. So it's usually HiRes. So what do I want to buffer for the object under it? It's its translate, rotate, and scale value. I want to zero it out. I don't want to use any frozen transforms, because they usually will make problems later in the rigging stage. But instead, I want to just zero it out in this way. So it's a HiRes buffer. And don't ask me where I picked it up. It's probably a long time ago. For some reason, because it could also be a scale, rotate, translate matrix. Probably was a project I was working on some years ago, where SRT buffer was used. And because I just find that SRT just rolls off the tongue easier than HiRes, I tend to call these things SRT buffer. So that's that. That's the whole reason why there are a lot of buffers within this hierarchy, and that's just because I want to zero out some rotational values so that I can actually hook them up or animate them easier. So there's this other thing which you can see here, which is called a SRT master. So master, as the name probably suggests, that's the thing you actually should animate. In this case, this is the control surface geo. I could just animate that. That kind of leads to problem if I have to swap out the geometry, if I have to change the geometry, if I accidentally change the geometry and introduce some construction history that probably interferes with my transforms, probably destroys the whole shape. Construction history is evil during the rigging stage. You don't ever want to have objects have construction history unless it's deformers. And you never usually need to change the value of any extrude or bevel operation on the object during the rigging stage. So you can of course do that if you want to modify geometry, but I'd say if you want to modify geometry at runtime, you're better off using Houdini instead of Maya. So the geometry tends to change. So what I usually do is I duplicate my geometry again. I'm going to display shapes. I'm actually doing so. I can just go a level deeper, and I'm just going to kill my shape, and I'm going to call this a SRT master. So with this SRT master, I don't want to parent it to geometry. I want to parent the geometry to the SRT master. So since I'm never going to actually select geometry as an animator in the viewport in any case, because I will usually have control objects that I can touch, which are far easier to select. I don't even ever need to select this geometry. There are other departments that might need to touch the geometry. It's there. But what I'm going to be influencing is this SRT master. And this, on the other hand, will be connected to some object that's in a completely different hierarchy that will actually transform this SRT master. And again, this SRT master has zeroed out rotation values. And I'm just going to transform that thing. So the reason, of course, as I said, the geometry might change. Might change. I'm just going to add a cylinder here. Let's say there's some small rivets or something on the control surface. I'm just going to move them there. It's a pretty big rivet. Don't care right now. It's a thing, a cylindrical thing. I'd actually never use that highly divided cylinders, but that's my standard, so that's that. Well, I probably combine them, which resets the rotational values. I don't care. Not have to do anything with them other than basically just parenting it to this master. And I'm gonna call them, because I want to keep them separately, because they maybe get a different material than the actual rudder. They probably don't, but they could. So I'm gonna call this control surface rivets geo. Yeah, and that's basically that. So all of a sudden we do have a quite involved and complex hierarchy, which totally makes sense. I'm gonna hide shapes here so we don't go a level deeper than we have to. So we have this stabilizer geometry group. We know that all of the geometry is in there. We can move that about if we want to. It's a purely organizational group in the way that I will most likely never ever change any transform values on this group. There's the geo in there. I can still modify it. I don't care. A level deeper is the buffer. I'm never going to touch the buffer. There's the master. The master is going to be touched. Somebody is going to animate the master directly or indirectly. And under there are the surfaces. I might sometimes generate a second group there and just call it geometry or whatever. In this case, probably should call it geometry group. Just to make sure that the geometry is kind of like bundled in the thing, or maybe there will be some other objects below this hierarchy just to have a level more. But usually I tend to not like too deep hierarchies, so I usually tend to just get rid of anything I don't need, because well, on a complex asset, and the plane is actually quite complex asset, but not that complicated compared to some other things that you can build. The nested levels of hierarchy tend to get really deep, and nobody wants to really dig through 20 levels of hierarchy. So you should always try to find ways to keep things as shallow as possible, but also as functional as possible. So if you need another level of hierarchy, add it. It's probably beneficial to everyone in the pipeline. Still, there are people that, or even yourself, like in this case, you still have to go through there and shade all those things and select them at some point. So you usually can use the viewport for that, but if you can't, or if you just prefer selecting things in the outliner, you probably don't want to dig too deep. So yeah, again, gonna close the second Maya instance here. And wait a little bit, because closing a program apparently takes longer than opening one. And coming back to our actual P51, the concept applies to pretty much everything. I might sometimes add a constraint to something if I want to make really sure that somebody knows that something is constrained to another object, especially if it's constrained in a way that I can't see a actual constraint. You can see that constraints are part of the hierarchy in Maya, so I can see them. If I connected objects through the node editor and directly connected maybe the translate z value of an object to another object's translate z value, I can't see that in the outliner. So if I want to make sure that I know that I'm transforming something by something else, I can add something that just explains to me that I do that. So in this case, that's a constraint. As I said, that was pretty loose with naming conventions. In this case, I tried to keep it logical, but I didn't want it to get too involved, and actually you can spend a lot of time just naming things. So yeah, didn't do that. So there's actually a camera parented in here. I'd probably delete them later, but actually there are a few control cameras in this hierarchy that actually make sense because they allow me to check and control a few things. So if I take a look at the cockpit cam, I can actually, when rigging an asset, I sometimes want to make sure that everything is functioning logically. So I'll probably animate while rigging to test out some parts of the rig. So I do have this cockpit cam, for example, just to make sure that from the perspective of the pilot, if I'm flying a curve, look out the window, I can see if the ailerons or any of the other control surfaces of the plane are moving as they should. I can see how much degree of freedom I should give them or anything else. And apart from that, it actually just looks cool, so I kept it there. Yeah. That's pretty much it for the hierarchy of the plane. The main gear hierarchy is much more complicated than the rest because there are a lot of objects that are actually controlling or influencing each other. So this actually goes down pretty deep. So not gonna go through this in this video, but we are gonna talk about this when we will take a look at the actual node connections. I'll not explain everything in detail, but the next thing we're gonna take a look at is the actual controls group and the rig itself. So I'll start by just showing you how it's structured and how or what things can be animated and why, and then I'll take a look at some of the node connections to explain how I set up some of the rig connections within the scene. I'm not going to go into everything, as I said, because it's a quite involved setup, but I'll just glance over some things and explain the general logic behind rigging in Maya. So yeah, let's continue with that. Or maybe before we do, I just spent a lot of time explaining naming conventions and talking about them. And while doing so, I noticed that some things in this setup might be a little bit confusing. As I said, I usually don't tend to add suffixes to everything because usually it's pretty obvious what things are based on their outliner icon and stuff like that. There's multiple ways Maya tells you that this is a polygon object. Well, technically, what I'm selecting here is the transform of the object, and the shape is the actual polygon object. But just to make things super clear, because this file is going out to you people that are new to Maya, maybe, and just to make it absolutely clear what's what, which will probably help understand the structure of the actual asset. I decided that I'm gonna rename a few things here, and I'm capturing it because there's a few things in Maya that are just not as easy as they sound. But there are a few little tricks that you can use. So why not start here at the rudder? I'll speed things up at a later time. So I'm just going to explain renaming some things. The first thing here is I don't know why I use the underscore here. For geometry, I usually just use camel case, and I can probably get rid of the detail here because it's just actuator, and I'm just gonna call that thing trim tab. So you can actually not add suffixes to names in any easy way. You can prefix hierarchy names, but you generally seldomly use prefixes. There is no obvious way to add a suffix to an object in Maya. But there actually is. You just have to know about it. So you can just go search and replace names. I've just got selected one object, but it'll still work. I'm gonna work on selected. And I'm gonna search for $, and I'm gonna replace with _G. So the $sign just tells Maya to keep the name as it is and to just add this suffix. So I'm not really sure where I picked that up. It's probably in the documentation somewhere, although I tried to look it up at some time while talking to people about naming conventions. I didn't find it. So yeah, but that works. So that's geo. So I'm gonna select the rudder, the tail light, and the actuator. I'm gonna go search and replace names. Gonna go with selected and put the geo there. So the same for all of these things. So geo and same with the R group. So geo. And I'd like to change a few things up here. So as I said, I didn't use the group suffix for most of the groups because again it's obvious, but to make it even more obvious to you guys what is an organizational group or what is actually a transform that is actively used as an object or a collection of objects that can be animated, I'm just gonna go here and add group to each and every one of those things, except for the pilot attentional, because that's not a group, that's just a point in space. So I'm gonna go geo. No, I'm actually not gonna go geo. That's a group. Everything is a group in here. So now on to the fuselage geometry. You can see that they're already named. Tail panel L, L7, L6. I don't actually like that. Maya puts some number there because when renaming a lot of things to the same name, Maya of course has to add a number at the end of the name so that no two objects within the same group share the same name. I'd like to rename those things. So the cockpit frame can just get the geo suffix, that's okay. And I'm gonna rename those fuselage panels to just fuselage panel. You can you have a rename tab here at the top. So I'm just gonna call them fuselage panel. So they're numbered now. And I'm now just gonna add the L geo as a suffix. So it's pretty obvious that it's on the left side and it's geometry. So I'm gonna go in and go with the flare gun hole, which is this little thing. It could just be flare gun hole interior. It's on the left side, so LGO is okay. There's actually no flare gun hole at the other side, so I didn't name it L, but I should, since everything else has the L in its name on this side. So this is gonna be just tail panel, and I'm gonna go in and add the LGO, and this can just go with the geo suffix. So this is how you go about renaming things, and this is just about keeping things kind of consistent. As I said, I'm not always a fan of adding a suffix to everything because it kind of tends to clutter up names as well. But as I said, to make things pretty obvious. I'm gonna go through that and change a few things here and there. I might do so in other places while recording these videos, because this is not the final version of the assets. Now I'm recording this video while still making a few tweaks and changes to the assets, but because of time constraints, and it took me some time to create this whole asset as an example for you guys. So as I said, I took a few shortcuts, and before giving it to the people in my actual VFX course, I'm gonna go through here and rename a few things. But I thought this renaming thing might be interesting for some of you as well. Well, at least maybe for the Maya users. I know a lot of users of other software might watch this video as well. You probably don't care for techniques of renaming things in Maya, but well, yeah, that's that. So I'm just gonna quickly go through here, rename everything, and then continue with the control group. So that's that. Everything is renamed, and it didn't actually took a lot of time, so you can actually just really do that simply and fast, and it's worth it. I'm happy with that. It's much more consistent than before. As I said, I didn't need to do that. The naming convention was okay-ish before, but I just think it's a little bit more obvious now. So little change to the asset while recording this video. So that's gonna be an edit 17. So after having saved the file, we will take a look at the actual rig.